Okay, so today we have two equations as well, but instead of graphing them to find the solution, we're going to solve them with algebra. Okay, there's two different ways to do this. There's using substitution and then there's using elimination. So we're going to go through both examples. So when we're using substitution, we're going to solve one of them for a variable and substitute it into the other one. So looking at these two equations, which one, the first one or the second one, would be easier to get a variable by itself? Why the first one? There's a reason.
Because once you subtract it from the other side, it's all negative, so if you need to divide it, just do it by it.
Okay, that might be one reason, but there's a better, even bigger reason. They're all divisible by the same number. Okay, so you're not going to deal with any fractions or anything like that. Okay, so now that we know we want to get the first one solved for a variable, we have to figure out, should we get c by itself or d by itself?
C. C. No, D. D. D.
Why would we pick d?
Because that's a smaller number.
If we got c by itself, we would end up dividing by 9, and then you would have a fraction, wouldn't you? And we're trying to avoid fractions. It's not impossible, it's just a lot easier to deal with integers. All right, so we're going to get d alone first. So I'm just going to recopy this so we have space to work. All right, so you're going to pick the equation that has a common number that you can divide out of all of them, and then you're going to pick the coefficient that's smaller and get that term alone. So first we want to move this. And then you can divide by -3. (3c plus 11). All right, so this process is called substitution because, like I said before, we're going to substitute this. So d is the exact same thing as 3c plus 11. Okay, so what we're going to do is we figured this part out so that we can now place this into the other equation and replace it with d. Okay, so what we're going to do is take this second equation. We have 6c plus 5. Then we're going to, instead of writing d, we're going to write what d is equal to, which is 3c plus 11 equals -8. And now all we have to do is solve for c, because we just have one variable now. So we're going to distribute the 5. Combine like terms. Move the 55. And then divide. Now yesterday when we were graphing our lines, what was the solution? Was it a single number? Was it two numbers? When we graphed the two lines, what did we say the answer was? The coordinate where they cross. Okay, so right now we don't have a coordinate. We have one of the numbers, okay, but we need to find the other one. So now we need to find d. Well, you can put it into either one of the original equations, or this one is the easiest one, because d is already by itself. So we take 3, put in our c value, which we just found out, and simplify. So what's that? 2? Okay, now this isn't x and y, it's c and d, but you're just going to write it as a coordinate in alphabetical order. So we got -3, comma 2 for the answer. It's doable. Okay, so we're going to go through the same process on this one. So let's make sure we know which one to pick and which letter we know to solve for. So which equation, top or bottom? Bottom one for sure, and should we get x or y alone? We'll get y alone. Okay, so looking at this bottom one, we've got to get y by itself. So we get y by itself. And then we make sure we don't plug it in. This is the most common mistake at this point, is kids will then just plug it back into the same equation that they used. Well, that's not going to get you anywhere, because you'll end up getting like 4 = 4 or something that's true all the time. So what you need to do is not do that. We need to put it in, excuse me, the other equation. So we're going to take 6x minus 7, and instead of writing y, we'll write what y is equal to. We get this. And when we distribute, we have to be a little bit careful because we're distributing a -7, so be careful of your signs on this step. Okay, combine like terms. Move the 77. And divide. All right, so we have one of our numbers. And now it would be wise again to use our solved equation here. So to figure out y, we're going to take -2, put in our x value. What do we get here? 1. So our coordinate is what? So that's substitution. The directions are going to tell you which method to use. We're going to go through the second method right now, but this is half of your assignment. They're going to ask you to do substitution. All right, so let's look at elimination before we jump to the homework. All right, so elimination is very useful when you look at your two equations and you know you can't solve one for a single variable without getting decimals or fractions. Okay, so what I've done, we have them lined up right here. We're trying to get the A's to cancel out or the B's to cancel out. Okay, so I know you've all seen this before, but it's probably been a couple years. What we're going to do is we're trying to add these two together and have the A's go away or the B's go away. But we need to multiply these equations by some numbers so that we get them so they do cancel out. So you can pick either the A's or the B's, it doesn't matter. Let's pick the A's. Okay, if we want to cancel the A's out, actually it would be easier to do the B's. How come? We don't have to multiply both equations by a number. Do you see that? What would we multiply the top equation by to cancel out with the bottom one? not 2. Really close to 2. -2 would be good. Okay? I'll show you why. So if we multiply this one by -2, which I'm going to just rewrite next to it over here. So now this is -6a minus 10b, which would equal +54. This one we're not going to change. Now remember, we're adding these together. So if you add -10b and +10b, that's where it cancels out and goes away. So they need opposite signs. So when we add straight down, how many a's do we have?
-2.
This is gone. And what goes over here? 8. Okay, so that means a is equal to -4. Again, not our answer, but part of it, because we need 2 numbers for the coordinate. Okay, so we need to take -4, and you can substitute it into any of the equations up here. Okay, it doesn't matter which one. So the bottom one?
Yeah.
So we've got 4, put our -4 there, 10b, -46. So we've got we'll add that. -30. So our coordinates, we put them in alphabetical order. -4, -3. So elimination, you're trying to eliminate one of the variables right away. All right, so looking at this one, up top, we were able to just multiply one equation by a number and have something cancel out. On this one, notice we can't. Okay, so sometimes we have to multiply both equations by a number, which is fine. So let's try to cancel the a's out since they're smaller numbers. What should we multiply the top row by? 2 would be a good idea. So if we multiply these by 2, what would we multiply these by? Now we don't need to multiply either of them and make these negative, do we? How come? They're already opposite signs right now. Okay, so we're going to keep them as opposite signs. All right, so if we multiply this through, got 10a, 30b, and -48. Here's -10a minus 30b, and this is 140. So what do we get on the left? So we get Is that true? Is this true? So what do you think we should write? There is a symbol. If you want to shorten it up, you can do that. What is true about these lines if there's no solution? They're parallel. They don't touch. Questions?